Couple of videos we spoke about the volumes of cubes and rectangular prisms, and today we're going to talk about more prisms and cylinders. So we'll start with a cylinder. So in the last couple of videos we spoke about calculating the volumes of cubes and rectangular prisms, and today we're going to continue and talk about more prisms and some cylinders. So to calculate the volume of a cylinder, we just do this radius times squared times pi, which is really just the area times that height, which is area of the base times the height, and that's what you do for all prisms, area of the base times that height. So if we were to say that the radius was equal to 3 and the height was equal to 10, then we would do 3 squared times pi times 10, that height. And that's just the area of the circle, 3 squared times pi, pi r squared. So you get 90 pi is the volume. Then if we were to solve for, let's say we were going to make another type of prism, a triangular prism, which is really just two triangles with a line, lines connecting them. And that distance, that line, that length, is what I like to call the height when I say area of the base times the height. Even though you may say, oh, well, that's the height. The lines connecting the two bases is what I like to call the height, even though technically it's not vertically upwards. So it can be a little bit confusing. Anyway, we would do, let's say that height is 6 and that is 3. We're finding the area of the base, so we're doing base times height, 6 times 3 over 2. That's the area of a triangle, which is 9, times this height, which I like to call height. Multiply, let's say it's 10, multiply by 10, you get 90. And I forgot to use units, so I'm going to put them in here. Centimeters cubed, the volumes are always cubed because they take up space. Squared is an area, so that area of the triangle would be 9 centimeters squared times 10 centimeters. And if you know exponent laws, centimeters squared times centimeters would be centimeters cubed, and then you get your answer, 90 centimeters cubed. So here are some answers. You should pause. Here's some questions. You should pause the video now. Try them out for yourself. I forgot to put some heights to a lot of these, so make up a height. For any of them that don't have a height, make the height equal to 2. I never purposely did put the height. So the answer to the first one, 4 squared times pi times 7. That was just a simple problem where you do area of the base times height. 4 squared times pi is area of the base times height. When you have a circumference, what you need to do is divide by 2 pi so you can get the radius, because 2 pi r is equal to the circumference. So to get the radius, you just isolate r and divide by 2 pi. So dividing by 2 pi, you get 10 over pi. That's the radius. You square that. It stays in centimeters. It's still a length in one dimension. You square that and then multiply that by the height, which we said was pi for this example. You may have said it was 2 because I told you to. Either way, if you follow the same format, you won't get the same answer, but it means that you're understanding it. It's the area of the base times the height. So the area of the base here was 100 over pi times the height. Oh, height is 2. Like I said, sorry, we were multiplying by pi to get the area of the base. I made a mistake there. So this says a prism. It's just to test your knowledge of prisms. I mean, this could be any type of prism. It could be a trapezoidal prism, like I just drew there. It just means that area of the base times height equals the volume. And if our volume is 400 and our area and our height is 10, then our area of the base is 400 over 10, which is just 40 centimeters squared because it is an area. And if you see centimeters cubed over centimeters, the one would cancel and you get centimeters squared. That's how you got the answer. The third question is probably the hardest question, and you need to know Pythagoras to get this question. So I'm sorry if you did this question and you were puzzled because you don't know Pythagoras, but hopefully you should know it. Sorry about that. Just going to fix that line because that was badly drawn. So once again, it's equilateral triangle, so area of the base times height, but to get the area of the base, you need to know Pythagoras so that you can say, well, the square root of 6 squared minus 3 squared, I wrote the wrong thing there, it's 6 squared minus 3 squared, because C in Pythagoras would equal that 6 there. That's C, that's A, that's B. And if you just rearrange it, B squared equals C squared minus A squared, T squared, besides B is equal to the square root of C squared minus A squared. So, you just plug in those variables. It's the square root of 6 squared minus 3 squared. You multiply by the base, which was 6, over 2, which is 3. 3 times the height, the square root, which is 27. That's the square root of 27 is just 6 squared minus 3 squared times that height. And I didn't put it there. You can put it as 2 like I told you to, but I'm going to put it as root 27 for my convenience because the square root of 27 times the square root of 27 is just 27. That's the definition of square root. Thank you. That's the end of the video.